a graphic that I use to help me when I plan my curriculum, because I think to help emphasize all of these higher order thinking skills and how they are applicable everywhere, anywhere and everywhere. And so I want to encourage you, and I know that you guys probably do a lot of this already, but one of the common things with math is to think about it in a linear fashion, as I mentioned earlier. With the GED, the attrition rate, we're going to lose a lot of our students before we get to the end, so it's important to start introducing algebraic concepts as early as possible, even in students who are just learning how to multiply. And so we came up with kind of 6 different areas that are often taught later in the curriculum, but can be taught as early as a student who's just learning their numbers. The translating, the word problems, the word problem factor, and that even includes translating a word problem into an algebraic expression. Students can start doing that really early, before they've really started learning how to solve equations even. Geometry and shapes. When a student learns how to multiply, a natural next step is to have them calculate the area of something, because it's the same skill. Coordinate planes and graphs. When a student is learning how to make a line graph or plot points on something, a natural next step is the coordinate plane. And then you can extend that into functions without the student needing to really know algebraic rules. They just need a rule that says like times 2 plus 1, and inputs and outputs. And then once you get to algebra, they're already comfortable with using a table to calculate and plot a line. Equations. I know Ben has done great things with teaching equations to students who are just learning how to do basic calculations. 7 times 3 equals 21, 7x equals 21. A student can start doing equations as early as they start learning how to add or multiply. Order of operations. That can be taught very early. Once students start to learn more than one operation, you can start to talk to them about what order they do these in. And then patterns. And we put patterns in there because a lot of critical thinking is just recognizing patterns. Recognizing the pattern in a word problem, where you see from this, okay, this fits a model that I've already seen, where I'm given the part and I'm given the base, so I think I need to find the percent. Or everything in math really exists in patterns. So if you start teaching students how to notice them and recognize them early, then it's gonna pay off a lot. And I've seen this in my classes. So that ideally, by the time you make it through the spiral and you've hit algebra, it's not scary, and the students already have a lot of the skills that they need to be successful in algebra. Does anyone have questions about this graphic? Okay. And I would also encourage you, this just has a whole numbers, fractions, decimals, etc. spiral, but I have another one of these on my desk that has like algebra and then has whole numbers, fractions, decimals, and percents around it, because even as you get higher, you should always be bouncing back and checking back in with what they've already learned.